We usually imagine musical instruments as magical objects. To a physicist, however, every violin and piano is a physico-acoustical contrivance, a rigid mechanical system governed by the laws of motion. For centuries, translating the feeling of a symphony into cold algebra was seen as an act of artistic desecration. Bridging that gap required a specific kind of physicist-musician who viewed equations and melodies as two sides of the same coin. This chain of events defines all acoustic music, a precise three-part framework of source, medium, and receptor. The source is the mechanical engine providing initial energy. The receptor is the destination, where vibrations reach the human ear and brain to be processed as data. This framework provides the mechanical blueprint for how sound actually reaches the human consciousness. Early efforts to understand the source began by treating vibrating strings as mathematical problems. One of the first to do this was Thomas Young. Young was a polymath who performed as a tightrope acrobat in the circus and spent his late nights formulating the mathematical theory of the string. In the early 19th century, French physicist Félix Savart took this clinical approach even further. He analyzed the body of the violin as a resonator, a purely physical device. Savart removed the strings, tapped the wood like a physician examining a patient, and glued wooden blocks to the instrument to map its vibration patterns. He eventually abandoned the traditional curved shape of the violin to build a mathematically optimized trapezoidal box. Musicians called it a coffin, but Savart designed it to be a perfect physical engine. By stripping away the artistic finish, Savart demonstrated that the musical source is a machine built to move air. At the other end of the chain, Hermann von Helmholtz set out to decode the receptor. Helmholtz was a titan of physiology and physics, who was the first to put musical harmony and the human voice on a mathematical footing. His research was often impromptu. One evening, exhausted after a day of work, the sound of a cricket on his hearth triggered a sudden physics experiment. By the light of the moon, he rolled cardboard into a tube and inserted it into his ear to calculate the natural frequency of the cricket's chirp. This work revealed that the ear functions as a synthesizer. It generates difference tones, sounds created by the listener's own anatomy that were never physically played. When two frequencies enter the ear at once, the brain subtracts one from the other to generate a third internal frequency. These discoveries suggested that listening to music is an unconscious exercise in arithmetic, with the brain acting as a high-speed calculator. If the source is an engine and the receptor is a calculator, can a scientist bypass the physical instrument entirely? In 1920, Lev Theremin was a cellist and communications engineer in Russia, working with early radio technology. He worked in a laboratory filled with capacitometers and radio panels, measuring the properties of gases. Lev Theremin noticed that his hands were acting as capacitors, working the invisible electromagnetic field around his scientific equipment. By moving his hands through the air, he could manipulate the pitch of a tone. He had discovered how to pluck the medium itself. Lev Theremin eventually learned to play beautiful classical melodies right out of thin air, using only his hands and electronic circuits. The sight was so unusual that his colleagues joked he was playing Gluck on a voltmeter. The instrument was so successful that Theremin was invited to perform a recital for Vladimir Lenin. He clearly demonstrated that a mastery of wave physics could produce the exact same artistic results as a traditional wooden instrument. For these pioneering physicist-musicians, science was definitely not an intervention in music, but rather a way to reach its core. They showed that the principles of frequency and resonance are the architecture of the musical experience.